got not one, but two speakers coming up in this next session. Let's bring them on to the stage right about now. Where you all at? Where you all at? Let's grab you, Abhishek and Jason. Yay! Did you guys win some headphones?
No.
We felt a little bit like cheating. Yeah. Oh man, I gotta go figure that out. While you all are giving a talk, I'm gonna have to go sort through a whole lot of chat data.
Maybe ChatGPT helps.
I was thinking that same thing. I'm gonna export it and say, who was the first person to answer this? There was a system overload, but I promise the chat, I will get you your headphones. If you are the rightful owner of those headphones, I am going to be reaching out. Now, Abhishek and Jason, you all want to share your screen?
Yep.
Let's get that rocking, and I will drop this QR code off for anyone that wants to fill out the open data survey and tell us how open your data is. There's the QR code, but scan it right now because I'm about to get rid of it. And you, in the meantime, hey, there we go. All right, I will be back very soon. I'll see y'all in a bit.
Yeah. All right. Thanks everyone for joining in. This is Abhishek and this is Jason. We're both senior engineers here at Amazon. Today we're going to be talking about how we power Amazon unit economics using Hoodie and a config-driven framework called Nexus. Some intro on where we belong within Amazon. We come under the worldwide Amazon Stores division, and under that we are part of an organization called Profit Intelligence. The goal of Profit Intelligence is to provide accurate, timely, and granular profitability data for Amazon stores globally. This includes one of them being contribution profit. Contribution profit is a very standard business metric that is computed across different companies. One simple example is if you ever bought a speaker from Amazon, our team pretty much computes the exact profit Amazon made, including the various cost and revenue segments like shipping cost, fees, and so on. This profitability data allows a large number of automated systems to make billion-plus decisions every day. This includes pricing, forecasting, and used by finance teams. Yeah, that's our intro on where we belong. So some history of our team with data lakes. We've been dealing with computing contribution profit for more than 15 years, which in essence means that we've been dealing with big data processing pretty much since the beginning. We initially just did the processing and published the data into a central data warehouse. But as the business requirements evolved, we eventually moved to owning our own data and maintaining our own data lakes for better control, solving the business requirements more easily. We've gone through a lot of iterations of data lakes. We have custom SC data lake with custom query language, unstructured Redshift ETLs on top of this SC data lake. Recently, we moved to consuming streaming sources as well via Flink. And the latest iteration is Nexus, which I will talk in more detail. At each of these iterations, the main thing is they were changing business requirements that drove these iterations. Given that we are kind of the owners for all the retail logic, to keep up with the business requirements and Amazon growth, we have to make sure our system is able to handle those requirements. In this, I'm just showing the quick preview of how we started ingesting streaming sources. And the main thing to here look at is we are using Flink for streaming, both in streaming mode and batch mode. And we have our own in-house Upsert data lake, which we built using Spark Blue. And we still have the Redshift ETLs. And in this iteration, we started isolating the business logic on the input side, and we had a little bit of control. But we still, because we were still using a custom solution for a data lake, we had scaling issues, and some logic was still in the Redshift ETL, so it was hard to make business changes. Our latest iteration of not just data lake but overall system is Nexus. Nexus is a config-driven data processing platform that allows customers to express their business logic. Customers here being the actual different business owners within Amazon Retail, they are able to express their business logic as simple declarative configurations. The expectation is that they only interact with this configuration layer, and Nexus as a system is able to go from this configuration to being able to produce the outputs by generating the relevant workflows, jobs. This kind of brings us closer to a self-service world where the business owners own their own business logic and they are able to make changes on their own without relying on the engineering team. This kind of solves the Amazon's growth and changing business requirements. At a high level, there are 4 main modules. I'll go over each of them briefly. We'll start with the Nexus flow. The main responsibility of Nexus flow is handling all the orchestration responsibilities. Each of the Nexus modules operates at its own abstraction level. Nexus flow operates at what we call as a workflow abstraction. Workflow here is basically a declarative configuration representing the workflows. Users are able to either define it by hand, or in most of our cases, it is generated from the higher order config that the business owners define in the configuration layer. Nexus flow handles this workflows in multiple layers: the logical layer and the physical layer. Logical layer is where majority of the magic happens in terms of building a logical tag, doing dependency inference, attaching runtime information. Physical layer is just a lightweight abstraction over step functions where the actual jobs execute. The overall theme of all the Nexus modules is it is very extensible. Let's say we have to add a new task type. It uses a federated model where you just add a new implementation and everything works out of the box. Next, we'll go over Nexus ETL. Nexus ETL module deals with, it represents pretty much the compute or the ETL data processing aspects of Nexus platform. We can treat it as a library that is able to go from a job abstraction, which is job defined as configuration, to an executable Spark job. Jobs, and in the slide I'm showing an example of a job, and job is defined as a list of operators, which kind of should be very intuitive from what we see here. The operators can be either built-in Spark transforms, or we can use custom user-defined functions. Currently, this Nexus ETL, we use Spark primarily, but the concept should apply to other data processing platforms as well. Next, we will go to Nexus Data Lake. This is the storage layer. Most of our tables are pretty much hoodie tables. This is where user-defined config on the higher order on the configuration layer kind of drives even the catalog management, including table creation, schema inference, and schema evolution. Sometimes we even provide configuration which gives hints on what distribution keys to use. All these configuration go hand in hand with the Nexus flow config, Nexus ETL config. All of them together kind of work together. Interact is all Nexus ETL and Nexus flow. There are future plans to kind of add control plane APIs to query the data. Yeah, that's on next. To learn with Hoodie using data lake.
Cool. Yeah, thanks Abhishek for going through the evolution of data lake. What is Nexus? So a lot of people you want to know since it's in the title. We built Nexus data lake, data store specifically, Hudi. For those of you who is similar to Iceberg, like we talked about. But yeah, comparing to Iceberg, it has a lot more functionalities that we are utilizing. However, they also come along with some learnings that we're dealing with here. The first one is concurrency. So originally, when we designing our table structure, we thought, oh, a couple of jobs right into the same Hudi table. This way, when there's a schema update happens in one of the jobs, for example, we want to move one column from one to another, because we have a monolithic Hudi table, it will just the transition just happens seamlessly, which is true. However, when we're actually running this in a shallow environment, we discovered because Hudi use this thing called optimistic, basically assuming for multi-writer scenarios, it will optimistically determine the insertion will go through. If there are two jobs writing to the same file, it's now actual shadow the recent years because there are a lot of two hours writing to the same file in this case. So we pivoted to this new table structure, and then use the aforementioned flow. We will handle an orchestration layer to determine when each of these tables have been completely observed. We'll run this join job that kind of the table output, either or incremental query, and that would produce this combined Hudi table. Okay. Another part of learning that we got was how Hudi manages metadata table. So it's enabled via this Hudi metadata enable config. So what metadata table is basically a smaller version of the table that sits inside your Hudi table that kind of keeps track of information like indexing, just like metadata information. When we start off running the jobs, we use synchronous cleaning. As we took a bit of time, so we thought, oh, just asynchronously. So we have another workflow that running that keeps cleaning off the table. So later on, we discovered despite the data being cleaned, the metadata table were not being cleaned, which we filed a GitHub issue for. The Hudi people were very keen on responding. We got to know it's physically fixed in later version. We were just using the older version, basically to ensure the metadata table gets properly cleaned. We switched back or we use synchronous cleaning. Process, we also discovered a bug on our end, why the file listing, why cleaning took a while. It's because file listing. Another section of learning we got was related to Hudi cost. So most of our tables are copy and write tables. In fact, all of them. Our update pattern for is about to one partition, the rest 30 to 60 partitions, and then we help they kind of evenly spread across 30 to 90 partitions. So with that, we have table. We discover about 70% of the costs requests, and then pull requests and get requests combined for about 80% of the cost. So even though due to customer requirement, we don't really delete our data, we found most of our costs related to Hudi are basically S3 requests rather than S3 storage. We do see that eventually changes as we store more data. So we looked at a couple of saving strategies. One of them being S3 intelligence seeding. It's like a feature from AWS that the backend automatically figures out if your data is frequently accessed or infrequently accessed or very infrequently accessed. We also tried more aggressive table cleaning, which is a feature that Hudi has that we mentioned before. It kind of cleans your data for you. And then we also try EMR autoscale, optimize our compute. Numbers. So as part of this migration project, we migrated so many jobs into Hudi. Probably about 300 SQL we to deprecate. A lot of them basically do the same thing, which is based. We maintain about 1,200 tables and increasing based on business needs, and each of the table gets updated about 5 to 15 times a day. The total data size for our data lake is about 4 petabytes, with about 1 petabyte gets added and deleted every month, cleaned every month. For our daily data size, every day we ingest hundreds of the days or they're either answered to us. And as part of using Apache Hudi, rather than in-house built data lake, we say about 1 year of developer days, because the Hudi is really just something we can just like pick it up and start using. Okay, that's probably about it for the talk today. We have a full version of the talk that we did for Hudi Community Sync. That you guys can scan the QR code, and the content of the talk is also converted to a blog, thanks to the wonderful One Health people, which is also in the QR code.
All right. Well, thank you guys very much. I appreciate that. Wait, keep that QR code up there a little bit longer. We lost it. We lost it. Get it back on there. I'll share it real fast, just so that people have enough time in case they weren't fast enough. Because, it takes a minute. You got to grab the phone, and then you got to get your camera out. I'm not that quick. So, you guys were awesome. I got to keep things moving. For anyone that has questions, drop them in the chat. And I am assuming you guys are going to be hanging around there and you can answer some questions that come through. For now, let's get to the next session. Thank you, fellas.
Thank you.
Thanks.